Greetings, everyone. I am Uday Sharma from the Triple Department of Institute of Aeronautical Engineering. Today, I am going to discuss about memory-aware embedded control system design. Memory-aware embedded control system design is a crucial aspect of modern engineering. With an advent of Internet of Technologies or IoT and other smart technologies, the demand for efficient and reliable embedded systems has skyrocketed. Embedded systems are the core of most smart devices, from smart homes to self-driving cars. These must be designed to perform complex tasks while consuming minimal resources. Let us see the challenges and opportunities in memory-aware embedded control system design and the latest trends and the techniques used in designing these systems, and how they can be optimized for performance and energy efficiency. Embedded control systems are a combination of hardware and software design to control a specific device or a system. These systems are often embedded in other products or equipment, such as cars, medical devices, consumer electronics, robotics, automation, etc. Embedded systems have limited resources and they are designed to perform the specific tasks. Control systems within embedded systems are responsible for making inputs and outputs, processing data, and responding to events. Every embedded system has a control system which manages the input, output, and analyzing, processing the data, and responding to the events, that is, inputs and change of the outputs. Let us see. Here, this whole system is called as embedded system. It has a software part, hardware part. In the input is given to the embedded system. Generally, a software input is given for let us take an example of controlling a motor. Software input is given to the application. The application changes the code into the understandable language of the microprocessor, embedded microprocessor. This microprocessor decodes, analyzes the code, and gives the output to the motor. Suppose if you give the code to increase the speed of the motor, the microprocessor analyzes it and sends the higher voltages to the motor peripheral device. Let us see, consider that peripheral device connected is the motor. Here, both the software part and the hardware part along together is called as an embedded system. And here we get the output as increase in the speed of motor. So embedded systems are given with a control system which controls the input and output designed to do a specific task. Memory hierarchy in embedded system refers to the organization of memory types in order of their speed and size. The hierarchy includes registers, caches, main memory, and secondary storage. Registers are the fastest and the most expensive type of memory, while secondary storage, such as hard drive, is the slowest and cheapest. The use of memory hierarchy in embedded systems helps us to optimize memory utilization and improve system performance. Let us see the different levels of memory hierarchy. We have level 4 of memory hierarchy, that is optical disc or magnetic tape, that is CD-ROMs or recorders, etc., cassette tapes, etc. Then comes the magnetic disk at level 3, main memory, which is the most important and prominent for and a compulsory thing for every device electronics to take. Cache memory is one in our hands. It is used for the faster response or faster performance of the device. Then comes the register, which every electronic device which comes with a microprocessor have. Memory constraints in embedded systems. One of the biggest challenges in embedded systems design is memory constraints. Most embedded systems have limited memory resources, which means that the designers must carefully manage memory usage to ensure optimal performance. Memory-aware embedded systems here, for explaining in detail, means with the having the little most memory or less memory or constrained memory, it should take the max out of it and give the best output or best performance. Let us take, so for example, there is an 8-bit of storage. Just the embedded system should control and utilize this 8-bit storage to perform all the given given output, given performance, and gives a max performance out of this. Or to say in other languages, if Generally, any embedded system takes around 120 something 120 MB of data to analyze this work or any system. The memory aware should complete in this given very less by consuming very less resources with a very less power consumption. Memory aware design involves optimizing the use of memory resources to its minimal power consumption and improve performance. There are two things to be quite taken into consideration, that is, less memory should be taken, less power should be consumed. These two are the important factors of a memory aware design or memory aware embedded system design. There are several techniques used in memory aware embedded system control system design, including the data compression, dynamic memory allocation, and caching. The techniques help us to reduce memory usage and improve system performance. As you know, the data compression is one we use regular day-to-day daily life to faster running or faster processing of the data. Memory management techniques. The memory management techniques are used to optimize memory utilization in embedded systems. These techniques include memory mapping, memory allocation, and garbage collection. Suppose these three are basic operations of any memory. First, the memory is mapped to a certain address. Memory reservation or memory allocation is the thing which is done when there is a certain level of instructions which have to be done in the set of memory. Suppose I have given an instruction further 10 more steps ahead, which needs the memory accessing here. So this memory is allocated to that set of instructions. Memory mapping involves mapping the data into the instructions and instructions into memory. Memory allocation involves reserving the memory for specific tasks or data as discussed. Garbaging is the collection of involves freeing up memory that is no longer needed. Suppose suppose there is an instructions which are no longer needed to the certain task, so there is no use with it now. It can be collected into the garbage data and dumped out. Energy efficiency is another crucial factor in embedded system design. Most embedded systems are battery powered, which means that they must be designed to consume minimal power to extend battery life. Memory-aware design plays a crucial role in improving energy efficiency by reducing the number of memory access and minimizing the time spent accessing the memory. There are several other techniques used in energy efficiency embedded systems design, including power gating, clock gating, voltage scaling. These techniques help to reduce power consumption and extend battery life, making them ideal for mobiles and IoT devices. Memory allocation. Static memory allocation is a technique that involves allocating memory at compile time. This technique is commonly used in embedded systems because this allows for efficient memory utilization and avoids runtime memory allocation. However, can result in wasted money if the allocated memory is not fully used. Dynamic memory allocation is a technique that involves allocating memory at runtime. This technique is commonly used in embedded systems because it allows for flexible memory utilization and efficient use of memory resources. However, it can lead to memory fragmentation and memory leaks if not managed properly. Real-time control in embedded systems. Embedded systems are often used in real-time control applications where timing is critical. Real-time control systems must respond quickly and accurately to change in the environment, making memory-aware design even more important in real-time control systems. Memory access time is significantly impact system performance. Suppose there is an embedded system of current protecting circuit. Let us say there is a current protecting circuit embedded system which protects from a fault current. How fast the embedded system acts to shut down the circuit if there is a short circuit occurs is what the embedded systems are mostly taken pride of or known for. So how fast it reduces, how fast it responds by taking the less power, less memory is what a real memory aware embedded system design is. To optimize real-time control in embedded systems, designers use techniques such as pipelining, parallelism, and hardware acceleration. These techniques help to reduce memory access timers and improve system responsiveness, making them ideal for applications such as robotics and automation. Let us example one of these topics as pipelining, which uses how the system uses less memory and faster processing power. If there is an operation going on, the data must be the memory address must be given. The memory is executed. The next memory address is given. Here, in general, what does basic system does is after this, the again next step is started. After this, it here goes. But in the pipelining architecture, while the memory is being executed, the next data is already fetched and ready to be executed. This helps in less time consumption of the execution or less time consumption of the CPU for it to execute the program. Memory optimizing strategies. Memory optimizing strategies are used to improve memory utilization and system performance in embedded systems. These strategies include minimizing memory usage, reducing data storage requirements, optimizing data access patterns, and using comparison techniques. By implementing these strategies, embedded systems can reduce memory usage and improve overall system performance. For example, memory optimization in autonomous vehicles. Autonomous vehicles rely heavily on embedded control systems and require real-time processing of large amount of data. Memory optimization is critical in these systems to ensure that the vehicle can operate safely and efficiently. In this case study, we will explore the memory optimization techniques used in autonomous vehicles and benefits of these techniques in terms of cost, power, and performance. That is, if there is an autonomous vehicle, it should analyze, suppose there is a truck behind this autonomous vehicle, in front of this autonomous vehicle. So the autonomous vehicle should fetch from this list of data how if there is a what to do if there is a truck in front of it. So how fast it can access is one of the major factors of this use of memory aware embedded systems. How fast it responds, how fast it can access this memory, how fast it can speed to the external device or peripheral device connected to it is what the embedded systems mainly used for. Security in embedded systems. Security is a crucial consideration in embedded system design, particularly in applications such as IoT and smart homes. Memory-aware design plays a crucial role in ensuring the security of embedded systems by preventing buffer overflows and other memory-related vulnerabilities. By carefully managing memory usage, designers can prevent attackers from exploiting memory-related vulnerabilities to gain unauthorized access to the system. Other techniques used in secure embedded system design include encryption, secure boot, and secure communication protocols. These techniques help in protect against attacks such as malware, hacking, and data theft, making them essential for any embedded system that handles sensitive data or information critical infrastructure. Memory-aware embedded controls design is a complex and challenging field, but is also one of the most exciting areas of engineering today. By carefully managing memory usage, designers can optimize the performance, energy efficiency, and security of embedded systems, making them ideal for a wide range of applications. As technology continues to evolve, the demand for the memory-aware embedded control systems will only increase. By staying up to the date, the latest trends and techniques in this field, engineers can continue to design innovative and efficient embedded systems that drive the future of technology. Thank you. This is Uday Sharma signing off.